Here is Math 1000 7.5. We are dividing radicals, and the problem with dividing radicals is we do not want to have a radical in the denominator. So the first thing we want to do is we want to rationalize the denominator. So we're looking for what the index is so we can get rid of that radical. So for problem number 7, I'm going to work down. We do not want a square root of 2 here. We don't want that square root, so we need another one to make a pair to get rid of it. Whatever you do to the bottom, you do to the top. So you're going to multiply across. So you have 1 root 2 over 2. And simplify when possible. Next one, you're going to multiply by root 6. So you have 6 moving across, 6 root 6 over 6. And these 6's cancel. Your answer is root 6. 15. Multiply both top and bottom by root 2 over root 2. So you have p root 2 over 2. In this one, because these are both the same square root, you can cancel that and cancel the 3 in here. So really what you have is 6 over root 2, and then rationalize that. So you have 6 root 2 over 2. And then there is one more thing. 2 goes into 6 3 times. So your answer is 3 root 2. All right, next, this column. Sometimes you need a different index. So in other words, you have 3 cube root here. So I'm missing 2 2's. So I need the cube root of a 2 and another 2 because I'm missing 2 of them here. So I really need the cube root of 4. Why 4? Because I only have 1, 2. I need 3 of a kind. So I need 4 here because I only have 2. If I only put a 2 here, I only have 2 2's. I need 8. So moving across, I have cube root of, I'm not going to say 2, 2, I'm going to say 4, over, now I have 3 2's, so that would just be a plain old 2. Number 37, hopefully you'll see this pattern. Number 37, it says that I need 4 of a kind here. So I only have 1, 2, I'm missing 3 to make 4 of a kind. Whatever you do to the bottom, you better do to the top. So what you have, 1 times this would be 4 through to 8, and at the bottom you just have plain old 2. Because 2 times 2 times 2 times 2, the 4th root of that is just 2. For 41, I need 4 of a kind, and I have a z here. I have actually 2 of them. So I'm only missing 2 more to complete my set. So that means I only need 2 more at the top. So we have 5 times the 4th root of z squared over plain old z. Number 45, I need 7 of a kind, but I have 4. I need how many more? 3. I need 3. I'm short 3 A's. So this is 2 times the 7th root of a cubed all over plain old a. 49, I need 4 2's. So I need 3 more. Really, I need 8. I need the number 8. So this is gonna be 5m moving across times the fourth root of 8 over plain old 2. Now, if this 5 were divisible, if 2 could go into 5, I would divide, but it's not. And this last one, I need 3 of a kind. It's the bottom that's the problem. I'm going to break this up for you. So I have the cube root 3x squared over the cube root of 2y squared. So the bottom is the problem. What's missing to complete 3 of a kind? So this is what we're missing. This is what we're short. We're short a couple of 2's, and we're short a y. If we have 3 2's, we're good, and if we have 3 3's, we're good. So that's what's missing to complete the set. So whatever you do to the bottom, have to do to the top to make it fair. So now we're just going to do the multiplication going across. So underneath the cube root at the top, this is going to be your numerator, cube root at the top, you're going to have 3 times 2 times 2. Well, 4 times 3 is 12. And then you're just going to have x squared y. And at the bottom, you've got your 2 and you've got your y. And you're done. Okay, we have some more of these. These are conjugates. These are easy because you're foiling, but you're noticing that you have opposite signs. So all you have to do is the outers, the first and the outers. And it's going to be 4 times 4, which is 16, and then minus root 5 times root 5 is 5. So you have 11. Number 58, 2 times 2, which is 4. And then minus root 7 times root 7 is 7, minus 3. 8 times 8 is 64, and then minus root 2 times root 2 is 2. 6 times 6 is 36, minus 7, which is 29. Now, why we need this is because we have fractions here, and we can't have a radical in the bottom. So we're going to rationalize the denominator. So what you're going to do is find the conjugate of root 2 plus 1. So the conjugate is root 2 minus 1. So you're going to multiply across. 1 times root 2 is root 2. 1 times negative 1 is negative 1. And at the bottom, you're going to FOIL it, but it's the same as up here. All you have to do is the first, so root 2 times root 2 is 2, and then minus, and then the last. So we know what 2 minus 1 is. That's your numerator, and that's your denominator. Next one, 68. We have root 3 plus 1 is our conjugate. So move it across. 4 root 3 plus 4 times 1 over root 3 times root 3 is 3. The next 2 will cancel, and negative 1 times 1 is negative 1. So now simplify. The numerator, there's nothing you can do. And 3 minus 2 is 3 minus 1 is 2. Now this you can simplify. 2 goes into 4 2 times, and 2 goes into 4 2 times. So you can simplify that. So you get 2 root 3 plus 2. 69, you're going to multiply by 2 root 3. I'm sorry, 2 minus root 3. So 1 times 2 and 1 times negative root 3. 2 times 2 is 4. The next 2 cancel. So this is simply 2 minus root 3. And number 70, you're going to multiply by 5 plus root 7. So 15 plus 3 root 7 over 5 times 5 is 25, and then minus 7. And this is going to give you 18. Now, is there a number that can go into 15, 3, and 18? And that would be 3. 3 goes in 5 times, 3 goes in once, and 6. So it's 5. The answer would be 5 plus root 7 over 6. And you are done with this assignment.